Hello, students, staff, faculty, and friends of CSM. My name is Kim Lopez, and I'm the interim president for the College of San Mateo. I want to welcome you to the first virtual International Education Week celebration at CSM. At CSM, we are proud to have a robust international education program serving international students from over 50 countries. To all of our international students, I am so impressed with your resilience and strength in the face of this pandemic. I applaud you for your dedication and commitment to higher education. We want you to know that we support your efforts and are so proud of your accomplishments. The CSM International Education Program team has planned for engaging and informative events throughout the week. They will feature current students, alumni, and other inspiring speakers from Silicon Valley. These events provide opportunities for our community to learn and grow from one another, as well as gain a new global perspective. Please enjoy this special week of celebration and be well and stay safe.
Hello, welcome. Thank you for joining us. My name is Aubrey Kwan Roderick. I'm the program manager for the International Education Program here at College of San Mateo. I am so excited you are tuning in to join us for the International Education Week. We have a special guest tonight. It is my greatest honor to introduce our opening session speaker, Chandrakant Patel. He is the Chief Engineer and Senior Fellow of HP. He is well known for his innovative ideas. He has 153 patents, and he has published over 150 technical papers. Over the past 3 decades, he has led HP in delivering innovations in chips, data centers, networking, print engines, just to name a few. Tonight, he will be sharing his insights with us on how we are entering this exciting cyber-physical era. Without further ado, let's give a warm welcome to our opening session speaker, Chandrakant Patel.
Thrilled to be here. In fact, my excitement knows no bound. And the excitement stems from the fact that the course ahead for us is very exciting. It is a cyber-physical era. In my talk today, I will define that cyber-physical era. And it is driven by socio-economic and ecological trends. Success will necessitate 4 Ps, and I'll start with that first. And that is the way indeed I've organized my talk. Success will necessitate 4 Ps: point of view, passion, pivot, and practice. Point of view is all of us must have a point of view in light of socio-economic and ecological trends. It is important because that point of view will determine the quality of life for current and future generations. So that's what I mean by point of view. In my talk today, I will elucidate that point of view, my point of view in that context, and I hope you will, in your Q&A today, if we have a chance or subsequently later, you will come forward with your point of view. Point of view is not sufficient. Given a point of view, one must have passion. Passion is not sufficient. One has to pivot. In my 37 years in Silicon Valley, I have had to constantly pivot from one subject area to another. I had to have multiple jobs, multiple different types. So that's what I mean by pivot, change. The 4th is practice. When you pivot, you enter a new area. So you'll have to learn how to practice a new thing. What I have learned in 37 years is the first 3 Ps are important: point of view, passion, and pivot. Practice. If you have the first 3 Ps, you will pick up practice. I have done this repeatedly over and over again. I entered a new area. Let's say I was doing disk drive design, and then I went into chips, completely new area. But because I had the first three P's, I learned by the practice by spending the time with fundamentals and doing, learn by doing. So you should not feel that you must know everything. Once you pivot, if you have the passion, you will be able to practice. That's going to be the message of my talk. And I will end by saying that if you have these four P's, success will also necessitate that you have depth in fundamentals and a penchant for multidisciplinary, inclusive collaboration. And that depth in fundamentals will come from your college education. I got it from my community college education and from Berkeley. And you will have to continue to hone it. And the multidisciplinary breadth will come from desire to learn other subjects. So if there's one thing you take away from my presentation, I hope it is this. Furthermore, I would love to see you keep this and use this as a template for your own growth. So when it comes to point of view, our point of view is shaped by our journey. Let me share with you how my point of view has been shaped by my journey. When I was a child growing up in India, I had pen pals in the US. Back then, we didn't have Snapchat or anything like that, of course, so we wrote letters. Those letters were very precise, very thoughtful, because it cost money to send aerogram all the way across from one end of the world to the other end. So we wanted to be very sure what we wrote. Very important lesson for you. Always understand what you are writing. By communicating with our pen pals, we learned that we learned and concluded that America was on top of the world because her children worked on their parents' car. They were tinkerers. They mowed lawns, they saved money, built radio control planes. They didn't care about status or hierarchy. They would do any job to save money to build things like model airplanes. It was a country of great infrastructure, like the Golden Gate Bridge. And by the way, our friends in United States carried Resnick and Holliday, Sears and Chimansky, the classic physics book that you have in your physics class at the community college. These high school friends of ours had that. We wanted Resnick and Holliday, but it was too expensive and we had to share. So we said America was on top of the world because her children were steeped in fundamentals. They were hands-on tinkerers. So that was a point of view. It was not a naive point of view. We were on top of the world back then because of that. I contend. It was the time when 747 was being built. I remember vividly taking my dad all the way to Mumbai to see the 747 that Air India just got in the early 70s. I came to the US in 1978. I arrived on Japan Airlines 002, San Francisco, went to Oregon. I didn't have any money. I had just come with $20. I had $10 that I got in exchange, $10 somebody gave me, so I had $20. I ended up in Medford, Oregon. I worked in a factory as a laborer. There is a story in San Francisco Chronicle that tells you about my history. Almost had a near fatal accident in that hopper that you see behind you. You will, please, if you have a chance, take a look. So I worked there, saved money, and then I took a Greyhound and came to San Francisco. I came to San Francisco because in the area where I lived, I could not find a way to get an engineering education. Corvallis was far away. There was nothing I could do. So I said, well, I want to go to engineering. So I said, let me just save money and then I'll head somewhere where I can work and go to a local college and go to a local university. So I came to San Francisco. I lived in a low-income hotel in the Tenderloin area, made great friends, learned from them. Someday invite me back and I will tell you the great experiences that actually made me. I I happened, the first day I stayed at the hotel, next day I walk out to 3rd and Mission, and I see number 12 bus. It says 12 City College. I got on that bus, I go to City College, and they said, we will take you. You have a high school degree, we will take you. The most powerful statement in my career so far is that we will take you. That is the inclusivity of United States. That is the inclusivity of community college. As long as a high school degree, they would take me. My concern was my grades were from India. It would take me time to convert. I had finished high school. So all I had to show was I had done high school. I went there on January 18th. School started on the 19th. I did my first 2 years at City College of San Francisco, transferred to UC Berkeley, got my degree in engineering, mechanical engineering, and went to Silicon Valley. In my early days in Silicon Valley, I worked at a company called Memorex. It is well known for its commercial. Is it live or is it Memorex? It's most of you will not recall that. Some of you may. It's a very interesting commercial. I'll let you take a look at it. There's a physical phenomena involved in here. I hope you take a look at it and send me an email of why that wine glass shattered. It's a fundamental phenomena that occurs. And I'll let you research it and send me an email. So I worked for the company called Memorex. And then I joined HP. And at HP, I met Bill Hewlett. I found him in the stockroom one day looking through wires and soldering wires and screws. And I asked him if he'd come to the lab. He came to the lab. And Bill Hewlett, the founder of Hewlett-Packard, a simple man, comes to the lab. He asked me to go through my lab notebook, how I'm designing experiments, how do I view the fundamentals of the work I'm doing, how will I prove or disprove my hypothesis. Very systematically went through everything. I concluded that early Silicon Valley was a valley of tinkerers. So my point of view, let me summarize. When I was a child growing up in India, I thought US was a land of tinkerers. I came to Silicon Valley and indulged myself in labs and tinkering, met Bill Hewlett. I found myself in the valley of tinkerers. Robert Noyce, Gordon Moore, the brilliant people who built the valley, the semiconductor business, the disk drive business. And my point of view, today's Silicon Valley it's a valley of abstraction. The abstraction is the internet. We sit above the internet with our cell phones. And there is torrid innovation in e-commerce and social media. Amazing. There are apps for everything. You know that. So what is missing in today's Silicon Valley, and indeed in today's world, oftentimes, not all the time, but more than ever, most of the times, is that we get so caught up in the apps that we don't go under the hood. We don't go and ask ourselves, where does our water come from? So if you're living in San Francisco, you have to know O'Shaughnessy, who built the Hetch Hetchy Dam. And you have to, when you go to Yosemite, maybe pay a visit to the Hetch Hetchy Dam. O'Shaughnessy fought tooth and nail with John Muir. Both of them were right. John Muir wanted to preserve the beauty of yet another Yosemite Valley in the area where the Hetch Hetchy Dam is located. O'Shaughnessy wanted to bring water. Because of their work, decades ago, we are able to get beautiful water in the region where College of San Mateo operates. It is imperative that we must know where our water comes from. Where does the waste go? Where does the power, electricity come from? It is imperative. Not knowing that is a problem. And I contend that we are so busy about the internet layer that many people do not know that. It's a fundamental thing you must know. We cannot just tweet for water. We have to know where it comes from, because in the future, due to socioeconomic, ecological megatrends, we have to redesign that infrastructure. We have to be O'Shaughnessy. We have to be John Muir. That's my point of view. US, a land of tinkerers, Silicon Valley, early days, a valley of tinkerers, Silicon Valley today, a valley of abstraction. So I hope that illustrates how our point of view develops. Given that point of view, this is my career journey. I won't go into it in detail. I use, as you can see by now, I use visual representations to represent myself and the work I do. In this context, There is an article I've written in LinkedIn. You can go take a look at it, how I draw this graph. This is what I call a visual resume or a visual CV. On one axis, I have my depth subject. Those are the subjects that's my mechanical engineering that I picked up at City College of San Francisco and at Berkeley. And then on the plus y-axis is the industries where I operated. And on the z-axis is my depth subject. Plus y-axis is the industry I operated. And on the x-axis are the breadth subject I picked up. Because as I pivoted and practiced new areas, I had to learn new subjects. Those are on the plus x-axis. So this is how I plan myself. And I have gone from district design to chips, to systems, to data centers, to city scale resource management. And now my interest is in 3D art to part digital printing and on computing. During this course, I have also worked as an adjunct faculty for 16 years at Chabot College. It's one of the most satisfying time of my career. 500 students from my local area, from Oakland, San Francisco, San Leandro, and various parts of the Bay Area. I taught them CAD, 8 hours every Saturday. Every single one of them, I placed them in great jobs. Google, just before it went public, one of my students ended up there. My students went to Synaptics. They were brilliant students. I was able to help them. I enjoyed teaching CAD, computer-aided design at Chabot College. I hope you ask me to come back someday and tell you about that experience. I also have taught as an adjunct faculty at UC Berkeley Extension, Santa Clara, and San Jose State. There I have taught heat transfer and electronic schooling. So as you see, my journey has been in industry, practicing as an engineer, in mechanical engineering, and in a breadth of subjects, not just mechanical. I had to learn data science, to the extent it is used in all the new jobs I did, from disk drives to chips to systems to data center. And that's the journey I hope you will take away as a key thing that you can pursue as well. So with that, let me talk about the future. The future is, as we look at the future, we must look at the socio-economic and ecological megatrends that are shaping the world. And the way I look at that is I look at the supply-demand frame. Supply is a pool of resources we draw from. And on the demand side are our needs: power, water, waste, transport. Water was the example I just gave, and HHE is a supply-side source. So think of that example. HHE is a supply-side source. It was built decades ago. Water comes and we take it for granted, take it every day. It's a fundamental need. So that's a classic example. So there's a supply side and the demand side. On the demand is power, water, waste, transport, health, finance, cybersecurity. All those are our demand side needs. And they are met by a pool of resources. Power, water, waste, universities. College of San Mateo is a supply side source, which creates human capital that becomes O'Shaughnessy, who built those dams. So it's a very important thing. It's the College of San Mateo City College creates Chandrakant Patel, who goes on to contribute on the demand side. That's how to look at supply and demand. The challenge we have is between supply and demand are these major trends and challenges that are shaking the supply and demand. Resource constraints. Now with changes we are seeing in our climate, fires, aging infrastructure, challenges like COVID-19 have become a perturbation between supply and demand. Your job is going to be, how do you create solutions given the perturbation between supply and demand? How will you create value-driven solutions that matter to society? That's your work. If you think about the world, here's the world you are entering. The 19th century was the machine age. It's the age of the steam engine and the power utility. The 20th century was the cyber age. The latter part of the 20th century was the internet. I talked about that. The 21st century is the integration of machine and cyber. It's the cyber physical age. You are entering the cyber physical age. It's an age of physical systems combined with data science. As you prepare for the world of tomorrow, you have to become a T-shaped contributor with great depth in one area. It could be data science, it could be mechanical engineering, it could be civil engineering, and breadth in many disciplines. It doesn't have to be engineering, it could be social science, it could be economics, but whatever your depth is, that depth is important, but you should also pick up the breadth. So you'll have to become T-shaped contributor in the cyber physical age, an age where machine comes together with cyber and creates integrated system. It is motivated by the trends we see. So for example, between supply and demand is a massive trend of aging demography. In our country, we are an aging demography. People who know how to run our power plant, how to know our trains are retiring. When they retire, who's going to run those? Those are critical systems. So you may come up with VR solutions that could help us do that. So you think of VR for gaming. Can we use VR where one expert person can manage many, many factories or many physical systems? Can we also use VR? Can College of San Mateo use VR to teach physical sciences and scale? Because it's very hard to scale. Can you imagine like Chandrakant Patel as a faculty at College of San Mateo and uses VR to teach not just only students at College of San Mateo, but teaches students all over the world? That would be scaling, because it's not sufficient that we teach something in one institution. People with knowledge are going to have to train hundreds of people, and those hundreds of people are going to have to train hundreds more, because the people who know our systems are retiring. So one person is going to have to manage many physical systems, and that same person is going to have to teach other people. And that's where VR will come into play. And so when you think of VR in that context, it's a cyber physical innovation that is needed to address the challenges of aging demography. So you see how that's going to shape the world of tomorrow. And these cyber physical systems are made up of stack of technologies. So that's a Tesla automobile. You can see that in the sketch. My daughter works at Tesla. So when she went to interview the first time, she says, "Dad, I'm going to interview at Tesla." So I said, "Okay." Like all parents, I keep a whiteboard in the family room. I love whiteboards, you can see in the back. I told her, "Okay, tell me how you size the motor in the car." I told her, sketch out the car, feel the wind, feel the friction, calculate the rolling friction, calculate the wind resistance. Thank you, City College of San Francisco, Physics 4A, Professor Oleg Rayout, thank you for teaching me that. Equations of motion. I learned that at City College. I told her to go learn that, use that. And then I said, why do they use induction motor? Thank you, Resnick and Halliday. I went to the book and I explained her, we used the book to figure that out. So you see, the stuff I learned at City College of San Francisco, I still use and I make my kids use it. So because you have to design that physical system, Tesla automobile, it's a physical system. You got to know how to design the motor, how do you size the motor? You have to know what actuators are going to be used, what sensors are going to be used, because you're designing that whole platform with all the sensors and actuators. If you don't design that physical platform with all that sensing and actuation and physical sciences, no matter how much software you do on top, it won't work. So I made her go through that. And then I said, okay, once you've designed the physical system, so it's got that physical domain knowledge, flexible actuator, that's the next one up. As you can see, I have drawn this stack. Flexible actuators are the ability to steer flexibly. There's an actuator that does that. Motor control. Rich sensing is sensing from LiDAR and radar. Connectivity is how do you connect the system. Once you go there and you connect that physical body, the bottom three layers are physical, the top layers are cyber. You collect the data, you analyze the data, and you use the analysis of data to create a control system that auto steers the car. It gets information from the road and it gives you an experience. So in the cyber physical world of today, it's all driven by experience. It's not, if you look at the cars of the machine age, it was a mechanical car. A car of the cyber physical age is a mechanical car. You must know the physical sciences, but you must also know data and data science. That's the moral of the story. If you got that, you've got most of my presentation. So I'm going to speed through the rest and close in 5 minutes. So what are some of the other things that are happening that you might want to be prepared for? Computing. Computing is going to change. Why is it going to change? Well, look at where we are with computing. I'll give you an example. Today, if you look and do a search, Katy Perry has 110 million followers. So her tweets are followed by 110 million people. And those tweets can be real time. The minute she puts something out, we are able to understand what she's going to do that day. She might go to a party that comes out. Similarly, Shah Rukh Khan, India's Bollywood star, when he tweets, people follow. They get information right away. So we can follow these people in the tweet. But we fail to follow airplanes. We have had crashes after crashes where data was being generated by sensors on the plane, like the pitot tube I show here. This was a crash many years ago where water got into the pitot tube, velocity information was lost. The plane that was cruising at cruising altitude had velocity anomaly, autopilot got disengaged. The pilot was disoriented, he lifted the plane stalled and fell into the ocean. It took us years to find the plane. Now, I have to ask myself, there's so much data being collected on the plane, almost a terabyte in a transoceanic flight. Why can't we get the data and analyze it and inform the pilot from the ground? The reason we can't do that is that's too much data. And sending it all the way back to the cloud, when you tweet or when you put your images up, it goes to a data center far, far away. It takes too long to go there and it's too expensive because it's too much data. Oh, how does that, what does that have to do with the tweet with Katy Perry? Well, Katy Perry, Shah Rukh Khan have taught us a lesson. What if we analyzed all the data on the plane and converted it to 148 character low bandwidth tweet? We seem to be able to follow that, but we cannot follow the large amount of data streaming. So the world of tomorrow is going to have lots and lots of data in factories, on airplanes. We will have to put computing back on the plane, back in the factory, locally, and create a local cloud to collect the data, analyze it, and only send 148 character tweets to the cloud. Then we will be real time. So the world of tomorrow is a cloud 2.0 where today's cloud with large data center will exist and will do well. We have enjoyed it. Hats off to that world of cloud 1.0 that was created. But tomorrow, you will be responsible for putting computing locally in factories, in offices, at College of San Mateo, at Berkeley. So all that rich data can be quickly had, analyzed, and acted upon. And you will send tweets up to the cloud. So see how my point of view has given rise to what I think we need to pivot to. Another example is 3D printing, another big opportunity. In 3D printing, imagine I was teaching CAD at Chabot College. I was teaching how to design. Now I will teach how to design, and that part will be digitally sent to a printer. The printer makes, in this case, you see a chain link. I designed the chain link using CAD tools that you use in your college. I transfer it to a printer. The printer prints that link. And in this example, you can see the link is used to lift up a car. The beauty of it is I didn't have to go to a hardware store, or thousands of links did not have to be kept on the shelves. I printed what I needed for what I needed for, in this case, to lift the car, and did it right away. Very, very powerful. The ability to go from art to part is very powerful. We are in the challenge of COVID-19. My colleagues and I published this paper. If you have a chance, take a look at it. During COVID-19, there was a need to create medical devices, then isolation rooms, personal protective equipment. 3D printing can help there. Can I scan my face and create a precise art of my face and print it? Of course I can. In 3D, you can. So 3D printing has been used to address this challenge. So 3D printing opens up huge opportunities. This is the world enter. But in order to be successful here, you're going to have to take the holistic perspective all the way from art to part. That means design's going to change. When I was teaching at Chabot College, I actually taught drafting, and I started on the drafting table. Then I taught my students AutoCAD, Inventor, SolidWorks, a variety of CAD tools. That was from the information age. In now the new cyber physical age of 3D printing, you will not think at a part level. If you're printing a part, you may not just pick up a part. For example, let's say a cap like this. You will think a whole system. You will think of the cap with the pen. So if you're thinking of a part for a car, you won't just think of a part for the car. You will think about the entire system, because 3D printing enables you to do contours that could not be done before. So you'll be able to shape things to make them more efficient. So if you're designing a cooling system, you'll be able to change the shapes and print many times different types of parts until you optimize the impeller in the pump, the channels that water flows through, to optimize the cooling system. What an exciting world. That's the world you are entering. But success here will require you to be strong in fundamentals. Remember, I just said, I still remember my City College books. In fact, Professor Jelinek at City College, Julius Jelinek, taught mechanics of materials. You come to my office and in 10 seconds, I will pull out his notes. I still refer to those notes because in 3D printing, when we create parts, we must know how to structurally analyze them. The mechanics of material using Van Vleck's book is still important to me. So if I have to use things I learned in community college at City College, you will have to know what you learned. Two things. If you want to know your fundamentals, respect your book, respect your faculty, stay tuned with fundamentals. Because the world of 3D printing is not just cyber, it is physical. How do you design the printer? How do you design the printer so it makes 3D parts? And then not only the printer, how do you design an entire factory? How do you power the factory? So just like that electric car I showed you, it's a stack of technologies. And on the right side, I saw the stack, very similar to the Tesla Model S stack. So you have to know your depth in fundamentals, and you have to pick up the breadth. That's the world you're entering. And then sustainability is going to be big in this world. So when you design a factory, you're going to look to see, can I build the factory net zero? In other words, I have a factory, it draws power. Can I generate the power with renewable resources? Can I use sun, which as the sun comes up, power is generated? And can I use other sources? My favorite source happens to be manure from dairy cows. So if I put a factory at a dairy farm, 2,000 dairy cows will generate a megawatt of power. That's a lot of power. That's a power equal to 1,000 homes. The manure goes into a digester, anaerobic digestion occurs. You use the methane to generate electricity. So if I put a factory at a dairy farm, have sun and manure, then the factory does not have to draw power from the utility. That's net zero manufacturing. That's the world you are growing. In fact, Governor Newsom just announced that in 2035, new cars will be all electric cars. Well, if they're electric cars, we're going to have to think, how will we generate the electricity? You cannot just think of the demand side that I have an electric car. You have to also think of how will you generate electricity. So I hope I made the point that the world you're getting into, you have to know your fundamentals, you have to know your physical sciences, and you also have to know data science. And with that, I conclude that it's an exciting world. It's an exciting cyber physical future. In 3D additive manufacturing, for sure, as I explained, but in just every cyber physical systems we build. And it will be imperative that you operate at the crossroads of people, profit, planet, and petabytes of data. That means you do things that help the people, that make money for your company, that help the planet, and use petabytes of data. If you don't operate at the intersection of those 4 Ps, people, profit, planet, and petabytes of data, then you may not be doing something useful. You may or may not be doing something useful. It is imperative we do that. We are being beset with challenges. Success will necessitate depth in fundamentals, multidisciplinary perspective, and learn by doing systemic innovation through multidisciplinary collaboration. The multidisciplinary collaboration will need diverse thinking. I find that I have learned a lot because I've traveled the world I've been with families from all over the world, from South America to Europe to India to China. And by being there, learning the culture, how people operate, I've become a richer person. And I've collaborated all across the world. Multidisciplinary global collaboration is going to be needed. So with that, I close with the message. Operate at the crossroads of fundamental domain knowledge, data, and data sciences. And I hope I showed you a story of strong point of view, passion, pivot, and practice. That's been my journey, and I hope it is yours as well. Thank you very much. And I thank the organizers. Aubrey, I thank you for inviting me. The faculty at College of San Mateo, the administration at College of San Mateo, thank you for inviting me. I hope you have a very successful day and look forward for further conversation in the future. Thank you. Bye-bye.
Thank you so much, Chandrakant, for this awesome and very insightful presentation. I feel very motivated to broaden my horizons after hearing your talk so that I can be more prepared to enter this cyber-physical age. And on that note, for the first question for our Q&A session, you mentioned a T-shaped contributor. So that was domain plus data-driven, and then depth as well as breadth. And you yourself learned mechanical engineering in school. And on top of that, you mentioned that you also picked up data management and data science as well. And so, you know, if there was a spectrum, I would place, if I were to place computer science in the middle, then I would place mechanical engineering on the left side and then data science on the right side. So I was wondering, how was the jump from mechanical to data science? And then like if you were to do it, if you did it, if you picked up data science while you were in the industry, then how was your experience? Were there any difficulties or even some similarities in the field?
First, I must say I commend you for that brilliant question. I speak in many a fora, and I rarely get such insightful question. It's a very good question. So thank you.
Thank you.
So for me, I think it's an interesting way that you put the spectrum. You described the spectrum, and I quite agree with that. For me, the way I picked up data management was in the late 90s, in 98, 99, I contended that the building is going to be the computer. Data centers didn't exist. So I said, massive buildings with lots of servers will become the computer. And that raised a very complex problem of fluid flow, energy management, and dynamic control system, multi-input, multi-output control systems. So in order to solve that problem, I found that domain itself was not sufficient. So I couldn't take the equations of heat transfer fluid mechanics. I had to use domain and then collect data from 10,000 sensors every 5 seconds in this massive 100,000 square foot room to manage energy, megawatt scale energy. So I had to start with domain, collect data, and come up with a formulaic representation of a model that could be used to control. So in controls, you need a model of the plant. I didn't have a plant model. The simple control system, you come up with the equation. Here, because it was complex, I needed to start with domain. I had to collect data and create the plant function. So that forced me to look at machine learning techniques, right? So it was a necessity. And so long before AI was a buzzword in social media, and today, we use machine learning, and we presented papers that won top-tier conference. They won awards for. One example was we collected data from thousands of sensors, analyzed them with data sciences to reduce the consumption of water in a data center in Bangalore, because water is very priced commodity there, right? So we used data science to build a system. And it was that learned by doing is how I picked up. I'm not an expert by any means, but I use the machine learning tools that existed then. Now the machine learning tools are, I would say, quite abundant. So I think that was the way I ended up picking it up.
Thank you for the very detailed answer. That was very insightful. And for the next question, it's about supply and demand that you mentioned in the beginning of the presentation. And you said that it is our job to create solutions given the perturbation between supply and demand, and to think about how we can create value-driven solutions that matter to society. So I'm wondering for you, was there any point or incident in your life when you were in a position to develop or use this valuable skill? An instance or like a real life example of when you observed this supply demand trend and then came up with or suggested a solution. Yeah, it would be great if we can hear your experience on that as well.
Again, a brilliant question. If you look back at my visual CV, so what happened was in again, the same, let's just use the example. I've had many examples. Look at the data center example. Our boss was Carly Fiorina. I walked over to her and said, these buildings are going to be consuming megawatts of power. 1 megawatt is 1,000 homes. 10 megawatts is 10,000 homes worth of power. This is the data center. Now, by the way, the data centers you use for social media or for e-commerce, all of those are massive data centers. Back then, they didn't exist, right? Today, they do. I predicted that they will require tremendous amount of energy, and we must develop solutions that reduces the consumption of energy. So you see, the supply was energy from hydroelectric power plants. The demand was the data centers. And I noticing that that's a problem, I developed the solutions. In fact, I became senior fellow at HP and subsequently chief engineer. That was a key contribution. Among the 3 major contributions, all 3 of those were driven by the socioeconomic trends and making a value-driven solution. The second one was city-scale resource management. So imagine cities, imagine like Singapore, beautiful example of a very planned or organized city-state, right? Working with bodies over there for sustainability. How would you manage power, water, waste? All those were opportunities I got, which were value-driven and which also helped me advance in my career. I would not be where I am had I not done that.
That's very interesting and great to hear that not only you gave back to society, but that also helped you as well.
It's much more exciting. It's much more. If I'm on the road and I'm on an airplane, I love that conversation. Would you love that conversation? Oh, sure. What are you working on? I'm working on water management. So that, think about it. I walk over to Lake Chabot here in San Leandro area. 800 Chinese immigrants use shovel to build that lake. We should bow to them for building the lake that supplies water.
Right.
So it is very important for us to learn what our ancestors did, how hard they worked. And if we could do the same thing, then we would be proud of ourselves and we would be proud. We will know that they will be proud of us.
Yeah, for sure. Yes. And so for the third question, it's about Cloud 2.0 that you mentioned. And you mentioned that as a system where we have some local data centers on a plane, and then they will analyze and synthesize essential data into smaller size and upload it to the cloud for faster and real-time reach of data. And you seem to be saying that it's an idea for the future while you were presenting, but I'm wondering if this idea, of course, it's not limited to just planes, but I'm wondering if this idea has been like widespread in the industry, or if there has been any attempts or first steps already taken to approach this.
It's interesting. The idea itself is not new. In the 90s, we had local computers. So you went into a company, you had a high performance computer. The workloads were engineering workloads and there were computers. With those data centers I talked about in the late 90s, this Cloud 1.0 became a big thing. It was very efficient. Lots of computers in one place, and instead of a company building their own IT center, they could rent computers in the cloud. And the cloud companies became very successful. And they are very good, extremely good. Look at today, you could rent the computers, you could do your finance application, your TRM is in the cloud tools, your HRM is in cloud, all beautiful, beautiful, beautiful. Hats off to them. The problem is we need to go back to the 90s again. Why? Because there is a ton of data being generated, like in your house, if you had a Ring doorbell, let's say you come to visit my house. If I'm taking a video of yours and then sending it and I'm subscribing it and sending it to the cloud, that's very expensive.
Right.
I would rather have my camera look at you, analyze, and I get a notification that Sue is at your front door. Why do I need the entire video? So what I'm saying is we are going to go back to computing the way we were. There will be high performance computing to do analysis inside the factory, inside the airplane. Notifications will go out. They will have small bandwidth. So that's why Katy Perry and Shah Rukh Khan, I thank you for teaching us a lesson. When you say you're going to go out to dinner tonight and all of us excitedly follow you, I hope we someday follow with same excitement the plane so we don't lose the plane. It took 2 years to find that plane, by the way. The pitot tube got into the water. It froze. All we had to tell the pilot was, don't do anything. Have a cup of tea. At 40,000 feet, the pilot lifted the nose up. The plane stalled, fell into the water. It took us 2 years to find the plane. Do you think that's not important for us?
No, of course. It's very, very important.
Oil platforms, planes, all of these. There is so much useful data that we can analyze on the spot. And that's what I'm saying. It's going back to the way we were. It's not being done as much, but you hear a lot of talk about edge computing soon. That's what this is. So I think the cloud that we know today is great. It will stay, but there will be an emerging cloud at the edge. One network hop from where you are.
That's very exciting to hear. And now I want to transition into some more general questions. And before that, I think I saw some participants wanting to raise their hands. I would suggest if you want to ask any questions to Chandrakant directly, I would suggest submitting to Q&A, and then I'll be reading the questions to him directly. Okay, so so you mentioned that you are chief engineer at HP Labs right now, and were there any major challenges you faced, and how did you overcome it?
So I think so. My role has been, if you again on my visual CV, I showed it. I was a technical contributor. I also ran HP Labs, reporting to my boss was Meg Whitman, who's the CEO of the company. After I did that stint, my management, herself and others, thought that this new position, which would be senior fellow and chief engineer, would be appropriate. The key contribution to becoming a chief engineer is the depth and breadth. Because you look at our company, we make ink. So that's chemistry.
Yes.
We do imaging and color. So that is dots and scanning and imaging. We make computers. We make 3D printers. We make 2D printers. So you look at our portfolio, it is important to have depth and breadth. So the answer to that question is, in order, if you want to become a chief engineer of a diversified company, you will need to have depth and breadth. That's one thing. And the second important thing is extemporaneous speaking. This is something I learned in India. Extemporaneous means is just like when I spoke earlier, I had no script. I spoke from the heart. I'm speaking with you. I didn't rehearse it. I don't have a script. I'm speaking for the heart. So the ability to extemporaneously speak without preparation, without script, is also very important. Because if you're a chief engineer and you're working with people from chemical engineering, mechanical and electric, you are always pivoting. And you are going from one context to the next. So being able to communicate extemporaneously plus depth and breadth is very important. That's how I got there.
Yes, for sure. So yeah, my second question I have here is, what kind of soft skills do you advise us STEM major students to develop in order to complete the job market? So I believe you mentioned one of them. Are there any other skills that you might want to push?
Written skills. So see, I learned English in India, and it was up to 12th grade. And when I came here at City College of San Francisco, I had that English 1A. I don't know if CSM has a similar thing called 1A. And like you went to Berkeley, I went to Berkeley. There was no English requirement in Berkeley. I was done, right? So luckily, I learned well in the high school. But when my son went to college, I told him, you're going to do a minor in humanities. So he went to University of California, San Diego. He did bioengineering. I asked him to join Ravel College and get a minor in humanities. So I think for engineers, it's very important. When College of San Mateo and City College and Berkeley ask you to take these additional elective classes, don't poo-poo them, don't complain, don't whine. Enjoy them, learn them. That's going to be very important soft skills. Do not make mockery out of these classes. I did not. I wish I had taken more. So I am constantly writing. Like as soon as you are done today, I'll be posting an article on LinkedIn on net zero and sustainability. I invite you all to join me on LinkedIn. Take a look at the article.
Yes.
That article has been penned in 15 to 20 minutes with a sketch. So I draw the sketch. That sketch you will see, I drew it in 5 minutes or 10 minutes using a 0.7 millimeter HB pencil, right? And so the way I'm able to do it is communication is very important. Written communication is very important. Knowledge of English is very important because it's a universal language. And then furthermore, social economics. Social sciences are very important. Economics is very important. I had my Berkeley economics book right here because I was developing a model right here. This is from my UC Berkeley Principles of Engineering Economics from 1982. I'm referring to it because I'm developing an economic model. I'm glad I paid attention to Economics 120. Learn economics. In fact, learn whatever they teach you in school. I typed it into the chat. Respect your teacher, respect your book, and don't do this PDF nonsense. Get a physical book. If you want to imbue it, get a printed book. I can remember sketches from my high school book on induction motors.
Yes.
You are in Berkeley ECS department. Professor Smith taught us Oldham and Schwartz. I had the book right here. I remember images from that book from 1982. Don't do this PDF. Get a book. I can still give you notes from City College. Respect teacher, respect notes. Those are soft skills, right? All of those are soft skills. Talk to people on the streets. Don't be stuck in the smartphone spending all day on social media. Go and talk to people. Look at the challenges they face. Those are all soft skills. That's social skills. It's not social media skills. It's social skill as we knew it.
Yes, yes, for sure. I can also attest to that because not only do they want those, not only companies want those qualities in their employees, it's even tested when you take interviews. So for me, I've been like for the past year, I've been interviewing for like job hunting for software companies, and in the interview, even in the interview sections, they would divide interviews into technical questions and then behavioral questions as well, where they will ask about your how did you communicate with team members, how do you overcome challenges, and then some other soft skill questions. So I think it's very important too.
You are an international body of students, so you get to know each other. When you go to India, ask your friends to immerse you in the culture there. When they come here, immerse them in the culture here. I think all of those are soft skills. That's the advantage. That is an immense advantage. Don't blow it.
Yes, yes, for sure. So there's a question here which is asking, what has been the most important decision made for your career?
That's a tough one, and
It is a tough one.
So I think in Silicon Valley, I had at least a couple of opportunities where I would have left my current job, and it was a job that was available to me. It was an offer sitting there, and I let it sit for 2 months. I did not go. I would have netted money that you wouldn't even believe, right? But I would not be sitting with you, Sue. I'll be probably in Cayman Islands. But I'm not that kind of a person. I enjoy greatly the interactions I have here. I think the most important decision I have made is staying true to mechanical engineering, never straying away from it, right? A lot of people, when Silicon Valley came about and software grew, they abandoned mechanical engineering and went into software. Nothing wrong with that. That's all good. I respect that. But I did not. But what I did was I kept my base and I picked up the breadth. That's the most important. So I still love second law of thermodynamics. The article today will remind you of second law. So please go read that article. I'm asking all of you who are on the call today, go read that article. So I stayed true to mechanical engineering, picked up the breadth subject, picked up the soft skills, and really enjoyed my job. The most satisfying job, HP has been awesome. I've been very fortunate to be at HP, great company. And I've been very fortunate in my academic part of my job. City College, Chabot College was just awesome. 16 years, every Saturday I was there. I never, because my students came from far away, I could not even just cancel the class because I didn't want them to come and go home. So that was very satisfying. So I think that staying true to my discipline, picking up the breath, helped me there, helped me at HP. I think that was the most important decision.
Yes, thank you so much for your answers, Chandrakant. And right now, I want to pass on to Moni, who might have some more questions.
Yes. Hello.
Hi.
Hello, Chandrakant. We have a question from the participants, the attendees. He or she is asking, how do you recall information from so far back, and how often do you reference old materials and notes? And was it always like this for you, or did you have to develop this skill over time?
Brilliant question. I must say, Aubrey, that your team here is just amazing. I'm so proud of you. I'm just very proud of you, the questions you're asking. It is the passion. Like, people might like a Lamborghini, the car. I just love all this information. If it makes you happy, then that's like yoga, right? So for me, this information makes me happy. But I think part of it is also I have a visual memory. You see all those drawings are all sketches I do by hand. 0.7 millimeter HB. I scan them. Joe, who's my colleague, who's on the call as well, she puts them on a cloud drive and I use them for my writings. So I think that helps me. Sketching, what I do is when I sketch, I abstract many things into a single visual. Like that supply demand is a single sketch that can be a cover page for 1,000 books. So what I do is I abstract everything to metadata, right? It's that Katy Perry tweet. Collect everything into a single metadata. That has helped me. So when I have a book that I went through at City College, I have abstracted that to a few pages with a visual. So Julius Jelinek teaching us in mechanics of material. The book he used was Van Black. I still have Van Black's book here. I have his notes, but I've abstracted them. The beauty of it is some professors like Professor Lightman, who's in Berkeley, he's still at Berkeley. He taught me dynamics. I'm a member of National Academy of Engineering. I run into them quite often. So it's good to remember them because I recall my notes. So it's more out of passion, being able to just sketch, abstract everything to a visual, and more importantly, not reading my book on an e-reader. I told my kids, books are not a burden. You're going to buy printed books. If you're going to learn something, if you want to imbue it, print it. It's the least joules transaction. If you're going to just scan it, now if you want to look up something really quickly to understand the meaning, yeah, go on the search and do it. But if you want to imbue it for a lifetime, print it. Get a printed book. This is why I can remember sketches from, like, somebody asked me the Tacoma Narrows Bridge, the collapse of the Tacoma Narrows Bridge. 1980, I go to Dan Hartog's book. Within seconds, I can go to the page that describes why the bridge collapsed, because there is a sketch in there and I could recall that sketch. I write about that in an article called Extemporaneous Speaking. It's on LinkedIn. So take a look at that article as well, because that'll be useful soft skills so that you asked earlier.
Right. Thank you for the very detailed questions, answers to the questions. And
brilliant questions, I must say. And I need it.
And I would like to move on to the next question that is, as the society relies more on degree as a point of entry to jobs, how would you advise future thinkers and dreamers to start innovating rather than being glued to school? Where should they start?
School, you said? Glued to schools? I didn't hear.
Yes, understand. Glued to school only.
Oh, I see. So in other words, the future innovators doing not only schoolwork, but additional innovation outside of school.
Yes.
So I'll give you my daughter's example. That's the easiest. So she's an engineer at Tesla. All three of my kids are engineers. The oldest one went on to become a doctor, so he's a surgeon. My daughter is an engineer in mechanical, then became industrial engineer. When she was young, I had a Ford Windstar, and oftentimes I would need to fix it. I would go with her to the junkyard, we'll pull out parts, and we would fix the car. So in the garage with my kids, we were always building things. So I think that they took metalworking, woodworking. One way to bolster your school is number one. Your college education, College of San Mateo curriculum is number one. In order to strengthen that, you could innovate at home by hands-on skills in building prototypes, maybe a passion. You may have a passion to build something, but build it yourself. It's not like Shark Tank, where you get an idea, you go to a bunch of Shark Tank people and you stay, I'm not talking that. That's also possible. I'm talking of hands-on building something, like my pen pals did when I was a child. America, the land of tinkerer. Be a tinkerer. That will help your school curriculum greatly.
Thank you. And I would like to move on to the next question. Based on your career and leadership experience, do you consider yourself an MBA critic or advocate?
You know, I don't have a point of view of being a critic or an advocate, but I have told the engineers, many of them have requested, should they had done BS in engineering and then wanted to do MBA. My recommendation is do masters in engineering as well before you do MBA, because you want to get a little deeper. But I don't have any, I'm not one of those guys who critiques whether it is, you know, an MBA or the other. But if you're going to manage a technical organization, if you have the MBA as your depth skills, then you need to pick up breadth in technology. So if you're MBA and your the depth is MBA, business administration, you better pick up breadth. By the same token, if you are an engineer, and like me, mechanical engineer, all the projects I sell, I needed MBA skills. I could not sell the data center without showing how we'll make money, how we will save money by energy efficient design, what will be the business model, how much will we charge the customer, what does the total cost of ownership model look like? Do a search, Chandrakant, Patel, data center, total cost of ownership model, something like that. You will see that I wrote that's like MBA skill, right? So I had to pick up that breadth. So I think MBAs can pick up breadth in engineering or technology and could be a good technocrat manager and vice versa. So I don't necessarily have a critique person.
Okay, thank you. And moving on to, I think it's our last question of today. It's about, you've managed global networks as interim director of HP Labs and HP Senior Fellow. Which, if any nation, do you see holding most potential on work in progressive technology?
What was that again? You'll have to answer.
I'm sorry about that.
Yeah, no problem.
You've managed global networks as interim director of HP Labs and HP Senior Fellow.
Right.
Which, if any nation, do you see holding most potential on work in progressive technology?
I don't think I look at it at a nation scale. I look at a global scale. Because, you know, with the globalization we have seen, we bring different points of view from all over the world. And I think that the challenge that we will be beset ourselves, whether it is climate or whether it resource constraints, we will all need to put all hands on the deck. I find when I go to Australia, I find certain strengths. When I go to Singapore, I find certain strength. I go to Taiwan, I find certain. I go to China, Shanghai, Beijing, I find certain strength. I go to India, I go to Hunjawadi, I go to Pune, I go to Bangalore. And it just, to me, it's just unbelievable. The kaleidoscope, the tapestry of talent we have. And what befuddles me is with such tapestry of talent, why are we faced with such challenges that we can't solve? It's ironic that we have such talent, such supply side talent, yet we can't solve simple problems. I consider a lot of the sustainability problems as simple problems that this tapestry can solve. I think that we are not putting our minds to it. To me, the supply side global pool is good. the demand side need is not being met because we are not focused on value-driven solution. So we are right back to where we started from, where I said we must make value-driven solution. O'Shaughnessy, go to Lake Chabot one day. You are all local. Go take a walk on Lake Chabot. Go to the sign where it says 800 Chinese immigrants you shoveled to build that lake, and bow to the people who did that. That's what's needed now.
All right. Thank you for your answer. And I think we are running out of time, so I will give this to Aubrey to end this event. Thank you.
Aubrey, what a
I
great,
know.
what
What
a
a treat
lovely.
for
I have
us,
yet to
right?
go on a fora where such questions have been posed. Many of these questions are very insightful.
Definitely, definitely. I mean, thanks to you for giving us this opportunity to asking you questions. This has been such a treat for us. I foresee that we're going to have many more opportunities to invite you back, perhaps. So I want to thank you all, particularly to Chandrakant. I know you're a very, very busy person, for taking the time to meet our students or answer so many questions. This has been so much fun. And thank you, the two moderators, Sulat and Monique. Sulat actually graduated last year. We're so happy that she can join us. And Monique is on his way next year to somewhere, we think somewhere in Southern California, perhaps. So we want to thank you all for joining us. This is our—
And on my side, Aubrey, before lest I forget, I want to thank Joe Murphy and
Yes.
our team, the executive IT team members who helped us. Frank helped us with Joe get this all organized in a timely manner. So
Definitely.
thank you very much to all of them as well for this.
Definitely, Joe. Thank you. And we can't forget about the work behind the scene David has put in to set up the webinar for us. So thank you, David, for doing that. And tomorrow we're going to continue with our celebration. Today we celebrated innovation. Tomorrow we're going to continue with inspiration. We have more fascinating speakers, just like Chandrakant. We have also alumni reunion for the first time. We are inviting alumni from the 1970 back to share their stories, their personal and professional journeys. So we hope you join us tomorrow. And I think David just posted some links in the Q&A or in the chat. For those of you who haven't signed up for the events for tomorrow, please do so. So with that, I would like to thank everybody again for joining us, and we will see you again very soon. Thank you. Have a great night.
Thank you. Thank you. Congratulations to all of you. And Sulat, you went from College of San Mateo to Berkeley, and you're heading to Southern California. Same path as I followed. You get invited back. Now the 70s alumni are back. I'm going to go tell City College, hey, how about inviting, I'm the 70s alumni. So maybe I should have gone to CSM.
That's right. Great. Thanks, everyone. See you soon.
See you soon. Bye-bye.
Bye-bye.